Hey guys, it's time to start working on my next project, which will be the console version of that tabletop Admiral set that I just restored. Tabletop was a model 16R11, whereas this console version is a 26R12, I believe. They're the same chassis, 21B1, although there were many variations of the chassis, so I imagine the run numbers are slightly different. I pulled this out in an earlier video, and as I recall, this one is a plain steel chassis, and it had a slightly older picture tube, so I imagine this is an earlier run of the chassis. So I'm going to clear some space off the workbench and pull this chassis out and just take a closer look at it. Here's the chassis. Like I said, this one's plain steel, whereas the one I just finished is copper plated. And this is a very early version. The other one I think was run 14, and this is only run 2. Also quite a bit dirtier, but no rust, just a heck of a lot of dust and dirt. Looks like the tube shields are missing. I would have thought there'd be a shield on this guy and this guy. I had pulled out this tube earlier. It did actually come with a tube. I think it was this guy. Yeah, that's a horizontal output tube. I have not tested anything in this yet, other than the picture tube, which is okay. So I will go through and do some quick resistance checks on the flyback and the yoke and so on to make sure that this stuff is good before I go any further. Oh, I will also pull out this rectifier tube and power the setup to make sure that the transformer is good. I pulled out the 5U4 rectifier and stuck my meter leads into pin 4 and 6, which are the plate leads there. And there should be 320 volts AC between pin 4 and 6 and ground, or if you measure right across both, about 640. Now, since I don't have any load on this, I would imagine it'll be a little bit higher, but it should be in that ballpark, 640 volts. And all the 2 filaments should light up. So, let's see what happens. Alright, 648 volts AC. And I can see the tubes are glowing. So, first test is good. Also notice there's a bunch of writing on the side of the chassis. Fleming, a phone number, some notes, bad sync, and various notes on other sides of the set too. That must have been from when the set was serviced way back when. Here's a closer look under the chassis. And right away I can see some differences between this and the other one I just restored. For example, there are no cup plates in this set. In the other one, there was one in the audio circuit, and there was one for the vertical integrator. This assembly here. Also, this is a bit different, and not just because there's some replacements in here. In the other set, there was the one candom resistor. I think they call them candohm, C-A-N-D-O-H-M, because the resistor is encased in metal, like it's in a can. They do that to dissipate heat. It's actually attached to the chassis. I suspect this one is bad, and they tacked in a replacement resistor across it, which is probably not high enough wattage. It should be 20 watts. Yeah, I don't know if this is 20 watts. They also tacked in this capacitor here, so I'm guessing that one of the sections on this is bad. Well, they're probably all bad now, but one of them must have gone bad a long time ago. So the other set had one of these guys and a resistor in parallel with it, and it did not have these two guys. It's just it's part of that part of the circuit evolved over time. Also, this set has a tube for the video detector, whereas the other set had a diode. The other set had something they called gated AGC, whereas this set does not. Not that it really matters a whole lot. That had to do with how well the set would respond to varying input signal levels. Really only a factor when you're trying to receive a weak station over the air with an antenna, but if you supply it right through the antenna jacks with like an RF modulator, you're going to have plenty of signal strength, so the AGC won't really matter. Number of repairs down here, new capacitor there and there. So this set has conventional American style resistors, whereas the other set they were all West German resistors. Alright, I'm going to grab my ohm meter and start checking resistances. They're all labeled here on the schematic. These marks in yellow are from when I did an earlier set and marked them off as I check them. I should probably print out a fresh copy so I don't confuse myself. I think we have a problem. I'm measuring the resistance on the vertical output transformer. In particular, I got it going between the blue and the yellow wire. I should have about 1300 ohms. I've got 11 meg. So I think we've got an open vertical output transformer. I figured my luck would run out eventually. This could be the first time I've ever come across a bad transformer, coil, yoke, flyback, anything. I've had quite a quite a run of good luck. So I'm going to unsolder the 3 leads and unmount this transformer, take a closer look at it. If it really is bad and it's not something easily repairable, like if there is a burn out on the winding, it might be near the outside layer and I can splice it. I can ask around online and dig through my parts. I do have a few vertical output transformers. I think I might have one that's somewhat compatible. I also do have another Admiral set with the same chassis that I picked up a few weeks ago, and I could borrow the transformer from that one, I suppose. You know, just to get this set running while I hunt down a replacement. I took a closer look at that vertical output transformer, and unfortunately I couldn't find a break right near the lead there, so I suspect it's somewhere deeper inside and just not practical to repair. Luckily, I don't think it's going to be all that hard to find a replacement for. It's a the Thord Arson replacement number is 26S52, and I found one website that seems to have one, and I think somebody on the Antique Radio Forum might have some, and I could ask around with other guys too. And I dug through my parts and I found a 26S54, which is similar. It measures about 1500 ohms, whereas this was originally 1300 ohms, and it's physically a bit larger, but I think it'd be close enough to sort of get the set working. So I started recapping, and I finished doing the audio output section, and I started working on the vertical oscillator section, and I tested this, which is the vertical blocking oscillator transformer, I believe, and guess what? It's bad too on one side. This side's good, but this side, it's measuring 2.7 meg. It should be far, far lower. 160 ohms. So what's quite possible is that this transformer went bad. The oscillator stopped oscillating, which kept the vertical output tube turned on all the time, which fried the vertical output transformer. Luckily the yoke is alright, I believe. At least the resistance measurement is dead on. So I need to now dig up one of these. When I was looking for the vertical output transformer, I did see that I have a few vertical oscillator transformers, but I don't recall what the part numbers were, so I'll have to go digging again. And if I don't have one, I'll have to ask around online for that one too. I've been working on this set a little bit more, and I keep finding more and more strange things, and mainly old repairs done with odd looking parts like these. These are resistors, and also some kind of ugly repairs like this. This should be a single 47 ohm 1 watt resistor. That's a pretty critical one. That's used on the cathode of the horizontal output tube. That's what drives the flyback. So there it is. And it should be bypassed with a 10 microfarad electrolytic, which is what this is. Well, I tried measuring the resistance from here to ground, and I was getting 0, which seemed strange. I thought maybe the capacitor was dead shorted to ground internally. And then I noticed this wire. And what's that going to? This lug up here, which is going directly to the chassis. That's grounded. So somebody dead shorted this point to ground, which is not a good thing to do. I can't imagine this was functioning properly. With that being a dead short there, there's going to be drawing a lot more current. The flyback does seem to be okay though. I did test the resistance and doesn't seem to be burned out. There's some other ugly repairs. Some resistors twisted together here. One of these just tacked in. Some stuff tacked in here. Also notice that when whoever did this would solder component leads together, they weren't twisted together or anything. They were just placed side by side and then a little bit of solder applied. Not exactly a strong mechanical connection. Also been finding a lot of stuff like this where the leads were left very long and it's just kind of tacked on there, just ready to fall out. Here's dog bone resistor. Found some more of those earlier as well. Here's another one where they cobbled together a couple parts. So I get the impression this was worked on quite a bit, probably by different people at different times, and makes me wonder how many of these parts are even original anymore. And given the two damaged components already, well, we'll see. I'll try to stay optimistic about this set working properly. I received a bit of good news today. A Video Karma member, KV Flyer, has kindly donated a couple vertical transformers to this restoration project. They should be here in a few days. It's a little sad how he came to possess them though. He bought an Admiral bakelite tabletop set 16R12, and it was destroyed by UPS in shipping. Cabinet smashed. Luckily though, he did save the cab, the chassis, and he dug it out and found those two transformers I need, so he mailed them off to me. I figure by the time they get here I'll be done recapping this set. which has turned out to be quite an endeavor. By the time I'm done with this, I think the only original parts left in it are going to be a few mica capacitors. So far, I'm just finding a mess in here. It's hard to say if these were the original parts or they were hacked in there. There's just so many different kinds of weird resistors I'm finding. I don't know if Admiral had to scavenge what they could and part supplies were tight, or if these are ugly repair attempts. Like, I found quite a few dog bones in this set, and a lot of cases like this where resistors weren't combined in series or in parallel. And as I'm measuring them, I'm finding most are quite a bit off, so I've been replacing all of them, and of course I'm replacing all the paper caps. So like, I'm done with the audio section to over here, and I got the vertical pretty well squared away. You can see how there's almost no original parts left. And now I'm working over here in the horizontal circuit, which was also quite a mess. What I found especially odd is there were additional mica capacitors tacked in that weren't originally supposed to be there, which led me to believe that, okay, maybe the original mica caps are bad. There's 3 of them in this area, a 470 and a couple 330s. So I got out a tester and tested them, and I was a little surprised to find out that they test just fine. So I just removed all the parts that had been added in and went back and I'm just going to use the original mica caps and of course some new resistors and replacements for the paper caps. So the device I'm using to test the capacitors is something I don't think I've shown you guys before. I've been using that solar tester previously, which works just fine, but I thought I'd give this guy a little whirl. I hadn't actually used it before. This is a Simpson capacitometer model 383A. This is unique in that you can actually test capacitors in circuit in many cases, and you do that with a 3rd lead here. But I've already clipped the capacitors out of circuit, so I can just use the 2 test leads. I'm not sure exactly how it works with the 3rd lead, but you clip that into the circuit somewhere, and supposedly it can compensate for any in-circuit resistance there may be. At any rate, it's pretty simple to use. You first select one of the ranges, anything other than pulse, and you short the leads 2 and 3 together, and you adjust this control here so that you get a full meter deflection. It's a line adjust, just like on tube testers. And then you simply clip the 2 leads across a capacitor and you read it right off the meter. Like, this is a 330 picofarad cap, and right there on 330. This is still has all the original components in it, and it works quite well. It can't do electrolytics though. It only goes up to 10 microfarads, and it doesn't have the right polarity. It uses an AC signal to test the caps. But for testing mica capacitors, it works just great. Also for measuring very high resistances. See his mega ohm range here, it goes up to like 1,000 mega ohms. Also has a mode called pulse, where it can put a pulse of up to 900 volts on a capacitor. It's a more rigorous testing for leakage than just putting a straight DC on it. I finished cleaning up the high voltage oscillator and output area down in here. Worked my way up to the sync separator and video output here, and now I'm up into this corner, which is the 5u4 rectifier socket, main filter cap, and some voltage divider resistors. I've removed most of what was up there because it's all bad, including this large CAN-dome resistor. Here are the other parts that were up there. So this was their replacement for the CAN-dome, and this was the replacement on the filter cap. One of the sections was bad, and here are the resistors, which are now out of spec. Capacitor looks especially bad. It's got some dry, crusty remains. So I suspect all the suctions are bad. I'll be replacing it with these 3 electrolytics. And believe it or not, this is equivalent to that large candom resistor. I figure I can maybe remove this or leave it in place just for posterity. And maybe mount this up in here, drill a couple new holes, put some thermal grease on it. This is housed in aluminum. That's what conducts the heat away, so once you mount it to something like this metal chassis, that will help dissipate the heat. And then here are a couple modern flame-proof metal oxide resistors to replace these 2 guys. I was curious to see how this filter cap would check out, so I pulled out my solar tester. And indeed, the one section of this cap that had been bypassed with this guy is pretty much shorted out. Even on the lowest setting, it has leakage and this light never goes out. I've tried reforming it by going to higher voltages as the instructions indicate, and I can never get this light to go out. The other 2 sections are also leaky, even at 300 volts, but at 100 volts I can get the light to go out, and they do register okay on the capacitance check, even though they should be good for up to 400 volts on the one section. So yeah, all 3 sections have problems, but this section especially is really bad. Just for the heck of it, here's a quick look at the replacement cap that had been installed. Should be 20 microfarad at 450 working volts, 525 peak. And yeah, indeed it seems to be okay. Here we're up to 400, no leakage. And as far as the capacitance goes, yeah, full eye, right about on 20 or so. A little hard to read this scale, 15, 16. It's not linear, so I'm not exactly sure what that second mark indicates, but it's somewhere between 15 and 40, that much we can say. So if I wanted to, I suppose I could use this guy, but I think it makes a lot more sense to go with a modern Nichicon 22 microfarad or 450 volt. The mail just arrived, and I've got a small little priority package which contains the transformers we need. So, this is a vertical output transformer. This is the vertical blocking oscillator transformer. I was warned these leads were a little loose, so he added some glue around them to stabilize them. Look to be okay. So these can be installed in the set, and it won't be too long before I can try powering this set up for the first time.